All right, so this video covers section 10.4, which is area and circumference. So we have some area formulas up here. Area is, remember, squared units because it's length times width or whatever, so it's units squared. Circumference is our perimeter for a circle. So perimeter for a circle is going to be just units, so whether it's just feet, just inches, whatever. And then our area for a circle formula. Remember that diameter is the whole length across through the center. The radius is from the center to the outside. So our radius is half the diameter. So find the circumference and the area of the circle. So they give us that the diameter is 14 yards. While we're here, we know the radius is half of that. So we know the radius is going to be 7 yards. So circumference, we can use either formula, either pi times diameter or 2 pi r, either way. Let's do pi times diameter. So we have pi times our diameter is 14 yards. So our circumference is 14 pi yards. This is going to be our exact answer, leaving it in terms of pi. And if it asks us to round, we have 14, and let's say we have our pi button right here. So 14 times pi will give us 43.98. So if we want to round it, it's about 43.98 yards. And that's an approximated answer. So make sure you read the directions to see what it's wanting. Same thing for the area. Area is pi r squared. So our area is pi times our radius, which is 7 yards squared. So 7 yards squared, so 7 yards times 7 yards will give us 49 times pi yards squared. So again, this is our exact answer. Plugging this into our calculator, 49 times pi will give us our approximate answer of about 153.94. Notice it's 9.3, looking next door is an 8. So that 3 is going to round up to a 4 yards squared. So circumference and area, whether it's exact or approximate by rounding, either way. Don't forget your units. So find the area of a figure. So I don't have an area formula for this crazy shape, but we do have the area formula for a triangle and for a rectangle. So if we make this a triangle, we can find the area of the triangle portion and add it to the area of the rectangle portion, and together we'd have our whole area. So area of the triangle. So area of a triangle is 1/2 times base times height. So this is a rectangle. If this is 48 meters, this will also be 48 meters. So our base is 48 meters. Our height, so our height is going to be a perpendicular line. I haven't used my whiteout, so let me just use it. So down here, this is 48 meters. So this is a perpendicular height. Over here, I know this whole thing is 23 meters. This is 13, so that must mean that 10 meters is left over. 23 minus 13 means 10 meters is left over. So this section up here is 10 meters, which is the same as this length. So we know our height is 10 meters. So plugging this into our calculator, 1/2 times 48 times 10 will give us 240 meters times meters, so meters squared. So that's the area of our triangle section. Now area of the rectangle. Is length times width, or base times height, either way. Our length is 48 meters. Our width is 13 meters. Multiplying those two together, will give us 624 meters squared. So then now to find our total area, we can add these two together. And we will get our total of 864 meters squared. So next example, same concept. Find the area of the figure. Write the answer in terms of pi, and then we're going to round our answer to the nearest tenth. So same thing, so exact and then approximate. So for one, we have a rectangle. I'm sorry, it says a square. So we have the area of a square. Again, is length times width. So if this is 6 centimeters, we know that they're both 6 centimeters, which will give us 6 centimeters times 6 centimeters is 36 centimeters squared. And then we have these half circles. So the area of the half circle. So the area of a circle is pi r squared, and it's only half of a circle. So we're going to do 1/2 times the area of the full circle, which is pi r squared. So 1/2 times pi. If this whole diameter is 6 meters, that will tell me that half of this, my radius, is going to be 3 centimeters. So our radius squared, our radius is 3 centimeters. So 3 times 1/2 is 3/2 times pi centimeters squared. I want to leave it like that because it says leave it exact, so we want to leave it in terms of pi and in terms of a fraction. So this is our area of a half circle. So if you notice, we have 1, 2, 3, 4 half circles. So we have 4 half circles. So we're going to multiply this number times 4. So 4 times 3/2 pi, which will give us 6 pi centimeters squared. So that's the area of all 4 of these half circles plus the area of our square. So our total area is going to be 36 centimeters squared plus 6 pi centimeters squared. I messed up. 3 squared is 9. So this should be 9. I'm sorry. This should be 9. So then this should be 18. And then this one should be 18. So this is our exact answer. 36 and 18 pi are not like terms, so we cannot combine them. So we just leave it just like this. This is our exact answer. And then plugging this into our calculator, we can find our approximated answer. So 36 plus 18 pi will give us about 92, rounding to the nearest tenth. So rounding this 5, looking next door is a 4. So it's going to say 92.5 centimeters squared. So that would be our approximated or a rounded answer. So next page. Find the area of the shaded region and leave it in terms of pi. So, looking at this, I see one big circle. So the area of the big circle. Area of a circle is pi r squared. So I'm talking about this whole circle out here. Oh, I did a great job tracing that. So this whole big circle. So looking at this, I can see that if our radius for the little circle is 6, so it would be 6, 6, 6, and then another 6. So then half of the big circle would be the diameter of a little circle. So our radius of the big circle should be 12. So pi times 12 centimeters squared. 12 centimeters squared. 12 centimeters times 12 centimeters is 144 pi centimeters squared. We're going to leave it in terms of pi. So that's the area of the big circle. Pi centimeters squared. Okay, so now I need to find the area of the white circles in the middle that are not shaded in. So the area of these circles. So the area of a non-shaded circle. Little circle. Again, the area of a circle is pi r squared. This radius is going to be 6 centimeters. So pi times 6 centimeters squared. So 6 times 6 is 36 centimeters squared, which is 36 pi centimeters squared. So there's 2 of them. So we need to multiply this by 2. That will give us 72 pi centimeters squared. So to find the area of the shaded region, is our entire big circle. So both of those circles are the 72 pi centimeters squared. It's this area of the whole red circle, 144 pi centimeters squared, minus the 2 unshaded blue circles, which is 72 pi centimeters squared. So subtracting these 2, we get our area of 72 centimeters squared. Final answer. Two more examples. It says find the perimeter and the area of the figure. Find the perimeter and the area of the figure. All right, so in order to find the perimeter, we need to add up all of the sides. I don't know the sides, but I notice that they're all right triangles. So we can use Pythagorean Theorem to find the different sides. So for one, let's try to find this one little side over here. Notice that that side is going to be the same as this side. So using Pythagorean Theorem, we know a squared plus b squared is c squared. A squared is 24. B squared is 7. And that will give us our c squared. So in our calculator, we have 24 squared plus 7 squared, which will give us 625. So 625 equals c squared. Taking the square root of both sides. So the square root of 625 will give us 25. So that way the square root and the square cancel each other out. We know 6 is 25 feet. C is 25 feet. So this length is 25 feet. So we're going to do the same thing for the other two lengths. So we know this length and this length are the same because they have the same bases. They have the same legs. So a squared plus b squared equals c squared. One leg is 18. The other leg is 24. So 18 squared plus 24 squared is c squared. 18 squared plus 24 squared will give us 900. Taking the square root of 900, we get 30. So this c value is 30 feet. So we know this length and that length is 30 feet. So now we know all the lengths of the outside, so we can easily find the perimeter by adding up all the sides. So we have 30 feet plus 25 feet plus 25 feet plus another 30. Which will give us a total of 110 feet. So for area, a couple of different things. The easiest way that I can see looking at it is that it's one big triangle over plus another big triangle. And these two triangles are going to have the same area because they're going to have the same base, the same height. So this big triangle and this big triangle. So you can find the area of one triangle, and there's two of them, so just multiply by 2. So our area of the triangle we know is 1/2 times the base times the height. Our base is 18 feet plus 7 feet. So 18 plus 7 will give us 25 feet. Our height up here is going to be 24 feet. So 1/2 times 25 times 24 will give us 300 feet. There's two triangles. So we have 300 feet plus 300 feet. So our total area is going to be 2 times 300 feet because there's two triangles, which is 600 feet. Final answer. Questions for me? So last example for these notes. Suppose you know the cost for building a rectangular deck measuring 16 feet by 20 feet. You decide to increase the dimensions to 20 feet by 25. So how much will the cost increase? By what factor? So, I'm trying to see the cost of building the rectangular deck. So it's going to be the area. So the area of the original (16 feet by 20 feet). It's a rectangle, so we know area is length times width. So 16 feet times 20 feet, which will give us 320 feet. Our new dimensions again, is length times width. So now we have 20 feet times 25 feet, which will give us 500 feet. So I need to see how much is it increasing, by what factor. So if we have our new area divided by our old area. So 500 feet divided by 320 feet. So in our calculators, 500 divided by 320 will give us that ugly decimal. So putting this decimal back into a simplified fraction, I just want to simplify this fraction. So second fraction of decimal, so second, the PRB button, will give us that mixed number. I want to change that mixed number into an improper fraction. So second, this next button underneath will change this mixed number into an improper fraction. 25 over 16. Final answer. So the cost of the deck will increase by a factor of 25 over 16. So that is all for 10.4 notes.